Sketch on each argon diagram the locus of the point z equals x plus iy, satisfying the following conditions. In each case, give the Cartesian equation or inequality of the locus. Now, this word locus often causes confusion. Z is a general complex number, but we're given conditions that it satisfies. The locus is just a line or curve which shows all of the possible positions of Z that satisfy the condition. Now, I'm just going to say that in this example, a lot of them, or all of these, are saying re-Z or im-Z. You won't see a lot of this in the exams. Indeed, they often ask you to identify particular loci or regions, and they forbid you from using re-Z or im-Z. But I've left this example in as it does give a good introduction to this idea of locus. The reason that they do this, that they exclude the re-Z and im-Z as part of your statement, is that the real axis here is the x-axis. So it's very easy just to say, well, re-Z is equal to x and im-Z is equal to y. So when I see re-Z is equal to -2, I can replace that quite easily by x equals -2. And then I can just draw on the line x equals -2. And that is my locus. But that brings me back to the word locus. Remember, it's the set of points, the set of positions of Z that satisfy the equation or inequality. And every single point on here has a real part, which is -2. And therefore the line represents all of the possible positions of Z. And that is exactly what a locus is. So for the next one, we can just say im-Z is y and negative re-Z is -x. So it's just the line y equals -x. And we know what that looks like. So it's just going to go diagonally like this through the corners of each of those squares. And any point you take on here, for example, here we have -3 plus 3i. The negative of the real part is equal to the imaginary part. Now here we have 2x minus y is less than 4. Now it's important to note that the boundary for this one is 2x minus y is equal to 4. So if we look at y being equal to 0, that would mean that x is equal to 2. If we had x equals 0, y would be equal to -4. So 2, 0, x is 2, y is 0, and x is 0, y is -4. The fact that this is a strictly less than means that when we draw the line on, we should do it as a dashed line. Like so. If it had been less than or equal to, we would have done a solid line. Now we need to figure out which side we need to shade here, because this is an inequality. So let's choose the origin, 0, 0. If I have 0 take away 0, that's equal to 0, and that is less than 4. Therefore, the side with the origin is the side that we need to shade. And you can always do a point test like this to decide which side you need to shade. Final one is re-Z multiplied by im-Z is equal to 4, which is xy equals 4. That's a rectangular hyperbola. If x is 1, y is 4. If x is 2, so is y. If x is 4, then y is 1. And that's probably enough points. We know the shape of a hyperbola. It's going to go like this. Also, if x is negative 1, y is negative 4. If x is negative 2, y is negative 2. If x is negative 4, y is negative 1. And again, we know the shape of a hyperbola. It's going to go like so.